In question number 20 on page 178, we're trying to find an integer to replace the box so that each trinomial could be factored. So they've given us the first term and the last term, and we have to figure out what the middle term is going to be. So what I've done here is I've put this into our box here. Because we have a leading coefficient here, we're going to have to be careful with the factoring because we can't just use that number. So the property we're going to use is that this diagonal product is equal to the diagonal across this diagonal is going to be equal to the product across this diagonal here. So I've already worked out the diagonal, this diagonal product. So 4s squared times 3 gives us the positive 12s squared. And what that allows us to do is allows us to split the middle term into these two areas here. And we can just factor this normally. That we need to add to that middle, but we have to have a product. That diagonal product must also equal 12s squared. So I'm just going to highlight that. So that diagonal product is also equal to 12s squared. So the possibilities that multiply to 12s squared could be 1s and 12s. Okay, so the s value for that first one could be 12 plus s, because that's going to add to that middle term. And so that could be positive 13. Okay, so that middle term could be positive 13s. So that's one possibility. This is for A. So we can have some other ones as well. So I'm just going to clear that out here. Okay, so those areas in here could still be equal to some other terms. So this could have been, to get 12, it didn't have to be 1 times 12. It could have been 2s. So it could have been 2s times 6s. And that would give us a middle term of 8s. Okay, so that would add together to give us a middle term of 8s. And so I'm going to put it in here. The other possibility is 8s. So it could have been 2 times 6, 1 times 12. We could have also used 3 times 4. So 3s times 4s would also give us the 12s squared that we need. And if we do that, we end up with 7s as the middle term. So it's going to, maybe I'll write it in here, 3s, 4s, and that's going to give us the 7s in that middle term. And those are the only possibilities that we could use for those two areas to give us that product of 12s squared. So this represents the set of solutions that we're looking for. Now, if you want to let s be negative, this middle term be negative, we could also say plus minus all these values, because we could have dealt with both negatives like that, and then we would have had negative 7. We could also generate a negative 8, negative 13. Okay, but for now, we're just going to assume that that's going to be positive.